Hello YouTube, this is Umozo3. So now we're on to a lesson in regard to while loops. And in the past couple lessons, we've been talking about this notion of a list. And we said that a list is basically a data structure in Python that allows us to hold multiple elements. And one of the nice things about lists in Python is that there's no requirement that the list be the same, that the elements in the list be the same data type. So if you look back in the previous two lessons, we saw examples of lists that have both ints and strings in them, right? And then you could also have floats, you could also have Boolean values, right? You could also have one of the elements be a list with other mixed elements in it, right? So we said that if you pass in two index positions, not only could you access an element within the list, but if one of those elements within the list is itself a list, you could access the index positions within one of those sub lists. But last video, the discussion of some of these methods and some of these functions that we can call on lists got a little bit quick at the end. So what I wanted to do is go through a very quick review of lists in the first 7 or 8 minutes of this video. And then we're going to introduce something called a while loop. And basically, if we have loops in our program, it's a way of iterating multiple lines of code without needing to write multiple lines of code. So what if you wanted to print the numbers 0 to 100? But you wouldn't want to say print of 0, print of 1, print of 2, print of 3, print of 4. You can probably think that there's probably going to be a better way to do something like that. But let's go ahead and go back to lists. So again, we can use the same example from the previous video. You know, a lot of the times I'll just keep the code that I had in the previous lesson. So remember, we were dealing with this list and we had a list of elements here, and these are all strings just by coincidence. Remember, you have to remember that lists in Python can have mixed data types in them. So we could have put a 4 in here, we could have put a true, we could have put a 2.6, and it would have not been a problem. And then we called this append method, and we said that if you call the append function on a list and you specify what argument, then it would basically add that element to the end of the list. And then if you call len of list, length of list, it'll just return the number of elements currently in the list. But what you have to remember is that's not going to be a constant, right? So you could have an original length of a list, but then if you append an element to it, then the length of the list is going to increase by 1. And then we also talked about this insert method. And you say if we have list insert of nx, if you pass in these two arguments, it looks at index position n, and it's going to put x there, whatever x happens to be. And then you ask, well, what about the element that was at index position n? And what we said is that all the subsequent elements in your list are going to shift one index position to the right. So hopefully that's clear to you. Everything just shifts over. You don't lose any information. It's not a reassignment. It's not saying at index position, I want you to replace what's there with this new thing. It's saying literally stick in this new thing there, and then everything else just scoot over and make room. So that's what happens here, right? And then we can go ahead and see. So if we do list insert of 0 in swimming, then we go ahead and get the 0 there before soccer, right? And then we can, hopefully you can understand. And then we also have this golf here because we said items.append of golf. So now after lines 3 and lines 13 are executed, our list looks like this comment. Okay, and then we can go ahead and insert into position 4 rugby, right? And then so there, what's that currently at index position 4? Tennis, because we said that lists start at index position 0. So what happens to the tennis? It's going to go to index position 5. What happens to the golf? It's going to go to index position 6. And then now we're going to have rugby at index position 4. And so we basically saw that, right? And then if we go ahead and we could go ahead and print that list if we wanted to. So now if we go ahead and run main.py, the executable Python file, we see all those sports, we see all the elements in the list. Remember, we inserted swimming at index position 0, we inserted rugby at index position 4, and then we had appended golf there at the very beginning of the program. So that's why you now have 7 elements instead of just 4. And we said, well, it's great to add elements to a list, but what if you want to go ahead and remove an element from a list? And so what you would do is you would do the remove method, and the only thing you specify into the remove function is exactly what element you want to remove. So before printing the list of items, which is what you can see on the console output, let's go ahead and delete one of the elements from the list. So what we're going to do, let's go ahead and get rid of soccer. So you could go ahead and say items.remove of soccer. And when you pass in this argument, it actually doesn't make a difference of whether you use single or double quotes. So we said that strings in Python usually can be enveloped either by single or double quotes. But then at the beginning, when we defined the list, we said soccer with double quotes, but now we're going to try to remove soccer with single quotes. And it still shouldn't be an issue to print a list where soccer has been removed. So now if you go ahead and run it, indeed, there's no more soccer on the console output. So those were just one of the methods that we were talking about. So hopefully you're familiar with the append method, which adds an element to the end of the list, the length method, which returns the length of the list, the insert method, which inserts an element into a particular index position. We have index of 3. Okay, so what if you call item, what if you say print of items dot index of, let's say, swimming, right? Because we had added swimming to index position 0. So now what we would do, we could make a little comment, and we could say that we would expect that code to return 0, right? And so there you see 0 at the top of the program. Maybe I should delete some of this other code down here just so that the rest of the code output isn't too distracting. But now if you go ahead and run this code, then it tells you that swimming occurs at index position 0. And then we said that in Java, if you try to find the index position of an element that doesn't exist in the list, it returns -1. But in Python, if you try to find the index position of an element that doesn't exist in the list, then we're going to get a runtime error. So if I try to find potato, it says that there's a value error. So potato is not on the list. It throws a runtime error. That's one of the fundamental differences between Java and Python. And then we talked about the max of x and min, right? So we need max, min, count, remove, and reverse. So there were a few others that we talked about. So we're going to try to do these quickly. So max of list, min of list, count of element, and then we talked about reverse, right? And then we also talked about, so max, min, count, remove, and reverse. I think we already talked about remove, but remember that if we have max or min of a list, right, max of list returns the maximum element in a list of just ints and floats, right? You can have a combination of them, right? But if you say max of list returns the element that would appear last in the dictionary alphabetically in a list of just strings, and you couldn't mix and match them. So if you have 3s and 2s and W's, you wouldn't say that W is the maximum or 3 is the maximum. That would not be considered a sortable list. It would not be considered comparable. But if you just have one or the other, right? So if you just have apple, right, and then you have xylophone, and then you have medium, right, and then you have pasta, and then you have bagel, right? And then if you say, what if you say print, and then you say max of r plus min of r. So what this is going to do is it's going to concatenate the string that would appear last in the dictionary with the string that would appear first in the dictionary. So now if you go ahead and run it, we're still going to get the runtime error from when we tried finding the index of potato. So now it's going to go ahead and try to run it. And you get xylophone apple, right? Because it concatenates the last word in the dictionary with the first word in the dictionary, right? And then you can go ahead and say 3, 2, 100, 5, 4. And then if you say print, what if you said max of r times min of s? So what this would do is it would basically print xylophone 2 times, right? Because xylophone appears last in the R dictionary, in the R list, and 2 would be the minimum in the S list. So now you go ahead and run it, and you get xylophone. So hopefully that makes sense to you. Hopefully you're clear with that. And then you have count. So what if you had said print of r dot count of apple? So that would print the number of occurrences of that string in that list, and it says 1. And then if you go ahead and insert another apple into here, then you could go ahead and run it, and you would get a count of 2 instead. What if you had said apples? You don't see the element apples, and so there's no problem. It doesn't throw a runtime error. It just returns a 0. So hopefully you're able to see this with a little more detail and just a little bit less of a rush here this time around. And then one more method that I really rushed and kind of butchered in the last video is the reverse method. So you actually just call a reverse method on a particular list. You don't set the result of it equal to anything. So what I can do is I'm going to come up with a list, right? So I'm going to say apple 5, 2, true, 3.6, orange, done. Okay, and then what I'm going to do is I'm going to say basically a dot reverse. So you basically just call this method by itself. Okay, it doesn't return anything. You just call list.reverse on a line. Okay, and what it does is it reverses the elements. Okay, so all index positions are essentially opposite in a way. So then if you go ahead and say print of a, and we want to print all the elements in the list, And then we go ahead and do that, and it says done orange 3.6 true, true 2 5 apples. So it goes in the reverse order. And so hopefully that kind of helps you understand with what's going on with that method. We have half the time left, and so I wanted to talk about loops. Basically, we're going to talk about a basic kind of loop in this video. So basically, a while loop is a way to iterate or repeat code multiple times. Okay, so we can have a block of code that will run numerous times, provided that a Boolean is true at the beginning of each iteration. So hopefully that's not getting cut off too much. But here's what's going to happen. The architecture is you're going to say while Boolean, okay? And then inside of this code, you're going to say this code will run as many times as the Boolean stays true. So let me give you an example of that. What we're going to try to do, so the goal here is going to be to write a program that prints all integers from 0 to 32, okay? And so the solution one is to say print of 0, right? Print of 1, print of 2, print of 3, right? And then this requires 33 lines of code, right? Because if you think about starting at index position 0 and you want to print 32, it's actually going to be 33 lines. Solution 2 is to use a while loop, okay? So you would use a while loop, and this requires like 3 or 4 lines of code, right? And you can see how this would be usually a much better way of doing something. So the technique basically is going to be to come up with and keep track of a variable that represents the number of times that we have already gone through the loop. So basically what you're going to do is, for printing the numbers 0 through 20, keep up with a variable that will change its value, across those numbers. So basically what you're going to do is you're going to say t equals 0. Okay, so basically what this is the first step in using a while loop. Okay, so basically this is the initialization of a counting variable. And so for many of the examples that we see, we're going to have a counting variable, and it's going to keep track of a particular status. It's going to keep track of basically how many times we've run through the while loop, because eventually we're going to keep checking to see if a Boolean is true. We're going to say while something is true, repeat that code, and it's going to repeat the code, and then it's going to check the Boolean again. So it's going to say, oh, okay, well, is that Boolean still true? If it is, go ahead and repeat the code again. If it's not, you're done with the while loop. So let me show you what I mean by that. The next step in a while loop is to specify. You're going to write the word while, and you can see it's a keyword in Python, which is why it shows up in orange rather than in white, right? It's like a special word, and it has special significance in Python. So you couldn't call a variable while, because while does something very significant and special in Python. So what you're going to do is you're going to say while, and then you're going to insert a Boolean. You're going to insert a Boolean. So you would say something like while t is less than 20. And we've talked about Booleans. We said that they're basically expressions that evaluate to either true or false. So as long as t has been initialized with a value, which it has, once t has taken on some value, then that gives us permission. It gives us the ability to evaluate whether or not that number, that variable, is less than 20. And obviously the first time through the loop, the first time you check the Boolean, you would be looking to see if 0 is less than 20, which it certainly is, right? And so I think we said we were going to go up to 32, but let's just say, so then let's just say 20, and I want to give you the idea, and then we can modify it. So what we're going to do is we're going to say while t is less than 20, I want you to print the current value of t, and then I want you to increment t. So let's do an in-place operator for that. So what this is going to do is it's going to print the current value of t. So when t is 0, it'll print 0. Okay, when t is 4, it'll print 4. When t is 18, it'll print 18. Okay, and what this will do is this is basically critical. Okay, so what this does is it prevents an infinite loop. So it allows the value of t to change so that we can iterate through the numbers, right? You wouldn't want to stay at t equals 0. What if you just said while t is less than 20, print of t? Well, then that would just say 0 is less than 20. Yeah, it is. Print 0. Okay, 0 less than 20. Yeah, it is. Print 0. Okay, 0 less than 20. Yeah, it is. Print 0. Right, and that's going to happen forever because the number 0 is always less than the number 20, but the number t is not always going to be less than the number 20 if you increment t every time you run through the loop. So this is going to have the effect of printing 0, 1, 2, 3, 4, 5, 6, 7, right? These two lines of code are going to happen every single time t is less than 20. But eventually t is not going to be less than 20 anymore because there's something that's happening in the execution of this program that's changing one of the variables, right? It's altering basically the status that we have going on here, okay? And you can see some PEP suggestions. So you can see a couple of lines being underlined here. I'm guessing that this comment is a little too long, right? It says you don't want to have a comment that's longer than 133 characters. But like I said, it's up to you whether or not you get bothered by things like that. So now if you go ahead and run main.py, what do we have here? We have printing of all the integers from 0 up to 19. So you can understand the first little bit of code, right? 0 is less than 20, so print 0, and then increment t from 0 to 1. 1's less than 20, so print 1, and then increment t from 1 to 2. 2 is less than 20, so print 2, and then increment t from 2 to 3. Let's think about later values of t. Let's think about 18, right? 18 is less than 20, so print 18, and then increment t from 18 to 19. 19 is less than 20, so print 19, and then increment t from 19 to 20. Is 20 less than t? No. So the last thing that you printed is 19. The final value that t takes at the end is 20, but 20 is not less than 20. So since this Boolean fails, t makes it to 20, but since this Boolean fails, by the time that it does, you don't end up printing 20. You just go ahead and stop at 19. But if you had printed the value of t after the while loop had concluded, you would see that t actually indeed makes it to 20, okay? And so we can think about ways to modify this loop. What if instead of saying t less than 20, we had said t less than or equal to 20? Well, now it's a slightly different Boolean, and now it prints the 20, right? And it's not just printing t after the loop, it's you know, printing t within the context of the loop. And so now you're seeing the 20 there. What if we had started at -10? So instead of starting at 0, we're going to start at -10, and that's just changing the initial value, and now you start at -10, so you're printing all those negative numbers. What if you had incremented by 2 instead of just 1? So we're going to start now at t equals 0 again, but instead of going up by 1 every time, we're going to go up by 2 every time. The only thing you'd have to change is the counting variable. And now you could go ahead and run main.py, and now you're going to get the even numbers, right? And then you can go ahead and do that for a wide variety of scenarios. What if instead of just increase, you know, what if you wanted to go down? What if you just wanted to go in descending order? What you would do is you would initialize t to be 20, and you would say, well, t is greater than or equal to 0. Now your Boolean changes, right? Because you're going to start from a larger value, and you're going to want to cut off, not if t gets too large, but actually if t gets too small. And then you would, and now instead of talking about it incrementing, you'd have to talk about it decrementing. So now if you go ahead and run it, it's going to print the even number starting at 20 and working your way back down to 0. Right? And you don't even have to just print the value of the counting variable. What if you wanted to do a little concatenation? So you could say t equals, and then we talked about concatenating strings. So we said that we could combine two strings, but we cannot combine a string with an int. And right now, t is holding on to an int. So the only thing you would do, we talked about this in lessons 4 and 5, is that you would say string of t. So you would do the string representation of t. And then if you go ahead and run it, you're going to get t equals 20, t equals 18, t equals 16, t equals 14. And hopefully that's clear to you with what's going on there. What if we want to do this for a string and we want to print the characters of a string on different lines? So we could do is basically we could say excellent or something like that. And then basically what we're going to do is we're going to keep track of a counting index, a variable. So we could say counting index that will iterate through the letters of W and print each of them on a new line. And we said that basically a list can be considered, a string can be considered a list of characters, and we can access characters, we can access letters in a string as if they were elements in a list. So then what you would do is you would basically say, while counting index is less than, and then you could just basically find the length of W. We're going to talk about how to get the length of a string. It's very simple, but you can see that there are 9 letters in it. So you would say basically, you would say while counting index is less than 9, you could basically say print of W of counting index. So that would print the letter in W at this particular index position, right? And then you would just have to remember to increment that index position. You have to remember to do that, and we're going to see the issue if you don't include this line of code, because if counting index never updates, 0 is always going to be less than 9, and this Boolean's always going to be run, and the code's never going to stop. And you can see why that would be a problem. But now if we go ahead and run this code, if we go ahead and run the main.py, you get EXCELLENT. And this is an example of talking about one of the lists, right? This is accessing characters in the string as though they were elements in a list, okay? And then this is incrementing the counting index so that eventually it will no longer be less than 9, and that would allow the loop to terminate. So these are a couple of examples, and we'll talk about some more in the next video. We're going to talk about a different kind of loop, but hopefully that's interesting to you. You can try your own examples at this point. So from UMozo3, thanks for watching, and please subscribe.